Thank you. Thank you, Andrei, for the kind intro. You didn't mention that I also know Romanian. Yeah, thank you so much. And yeah, before I start, just want to take a moment to again appreciate and congratulate everyone here, everyone that's been part of tim.js, either from the beginning or just jumped on the ship while it was sailing, and it's still sailing. People are still jumping, hopefully, on the ship, not off the ship. You know? So yeah, big congrats to everyone here. A huge round of applause again for everyone that's involved with tim.js. As a community organizer myself, I just know how much effort it takes to have this kind of the level of consistency and being able to do events on such a regular basis. So again, yeah, my name is Alex. I'm coming from Cluj. I'm not going to speak about JS Heroes because Andrei already took care of that. Just next year, if you're interested, it's going to be on the 14th and 15th of May. And we're going to soon announce the first speakers and everything else, probably around beginning of November. I work as a product engineer at a company called Together AI, which most of you probably haven't heard of. You might have heard about the previous company I was working on, which was Code Sandbox. Code Sandbox in October got acquired by Together AI, so now I am doing AI. No, I'm not doing AI, sorry. I have to do this. Yeah, probably I'm one of the least passionate people about AI inside the Together AI company, but it is, I would say that it is interesting, the things that we are doing. We're a hardware provider for other companies and for individuals that want to run different services related to AI, from fine-tuning to inference, and we go all the way to renting out GPU clusters and custom configurations for more enterprise level solutions. All right, enough about that. The topic of today is not about community, nor JS Heroes, nor AI. It will touch briefly on that, but I'm going to put a big disclaimer when I'm going to do the AI slide, because as Ben mentioned, you have to have AI in a talk in 2025. But the disclaimer now is actually that the things that I'm talking about are not researched in any way. They're not there's not been a big effort to push these things. It's more my observations, my own opinions about the things I've seen across the years, the things that I've seen that apply positively on Codebases. And we're going to talk about exciting stuff like code and folder structure and things like that. But most importantly, we're going to talk about what I call long-term projects, right? If your job involves coming into a project and shipping something, building something from scratch, doing an MVP with whatever's the latest technology stack at that point, and then moving on to the next project and so on, then maybe this talk is not exactly addressed to you, but hopefully you will still get to learn a few things from that. This talk is mainly addressed for, again, what I call long-term projects. And I had the privilege of working on a lot of these projects in the past 10 years or so, from startups to product companies, scale-ups, whatever it was. And what these code bases have in common is that they were maybe started 4, 5, 6, 10 years ago, and they will still have to run probably 4, 5, 6, 10 years into the future, maybe even more. So the key word, or the key thing around this is how do you make sure that the code that you write, the code that you write today is still relevant 5 years from now or 10 years from now? Or how do you make sure that the code base as a whole, stands all these external pressures that get applied to the code? And some of these external pressures, external or internal pressures. What are these pressures, right? So on a piece of code, on a big code base, you can have the product roadmap be a big push for attention, right? Because the roadmap might say, oh, we're going to build this feature A, then feature B, then feature C, but maybe after 3 months it's feature C and then feature B. There are all these different changes, and especially on a bigger product team, you will have this kind of shifts in priorities and shifts in what you ship, when you ship it, and for whom are you shipping that thing. If you go one step level, you can have business priorities that are changing. The product that used to be built for all the users out there, for a very customer-centric user experience, now it's all of a sudden required to run for big enterprises. So all of a sudden, half of the things you've built have to be repurposed for some maybe completely other scenarios or contexts of use case. Time itself is a pressure that gets applied to the code, right? Because start 10 years ago and you have a Webpack config in your project, so good luck maintaining that in 2025. Whereas with other tools you can start fresh, but you maybe don't have the luxury on that particular project. Internally, you can have things like architecture changes, right? That usually look like, I'm not sure if you've been through that, but usually look like driving a car and changing the wheel of a car while it's driving on the highway at 130 kilometers an hour. You kind of end up with two architectures for a long, long, long period of time until you're actually moving on with a new architecture. One thing that's often omitted is staff changes, right? The team that started those 5 years ago might not even be in the company anymore. And people that made some decisions about how we want to build things, what are our guidelines, what are the best practices we want to use. Maybe they're not there anymore and other people joined in and now they have different ideas about how the code should evolve and change. And last but not least, you have just tech stack changes, which are very common, right? You want to build with new libraries, you want to upgrade to new frameworks, you want to change, whatever else is involved in the general tech stack. You want to introduce server-side rendering, whatever it is. So the question here is, how do you build this layer, this protective layer? How do you make sure that the code base stands all these pressures that get applied to it? And the keyword we're looking for is resilience, right? How do you build code that is resilient to all these different changes, or that is in the best position to survive or to help you, guide you through all these changes? And of course, there are a ton of things here that you can build for, or there are a ton of different things. But the one particular thing that got me very interested over the past few years is this notion of co-locating code. And actually, it's barely visible, but I wrote this article back in May 2024 with some of the ideas I already had. I was kind of trying to figure out, okay, what are the things that are making the code bases resilient to all these different changes? So, what is colocation? What am I talking about even here? Colocation, or the proximity principle, ensures that coupled code units are also physically grouped together. I'm using here the term code unit. You might be think of it as code component, but I don't want to mix it up with actual UI components. A code unit can also be a function, as you will see in a couple of examples. Basically, it means that code that is coupled, code that makes sense and runs together should also live physically together, whether it is in the same file, in the same folder, or just in the proximity that is strong enough that you don't have to move around in different contexts to figure out what the hell is happening in this code. This is actually more or less what separation of concerns actually tells us to do. Modern separation of concerns. For a long time, web development used this kind of separation of concerns, right? Your HTML was in one place, your JavaScript was in another place, and your CSS was in another place. And then, right around when the whole React revolution started, we started using this kind of separation of concerns, right? By components, in the sense, in the context of React. But I'm taking it one step further. And I'm calling, and we're going to see this common thing. I'm going to call all these things different domains of your application, right? We're not going to talk about React in particular. Doesn't even relate to pure front-end here. This is more like, how do you split the whole of your code, your hundreds of thousands of lines of code, into units or domains that kind of make sense together, make sense, independently, so to say. And let's take a piece of example, like a code here. Of course, it's React, but whatever, it doesn't matter. It can be anything. Let's say you have to build a hardware list component, right? Don't need to worry about the specific here. It's just you're fetching the hardware and then you're rendering a list. That's pretty much it. And what I want here people to do, not necessarily focus on the code itself, but more try to try to imagine this, being more complex, but here is a very simplified version for the sake of the slide and of the explanation. And try to think of this as this is the evolution of the code, right? Originally, the feature is just, let's see if we can render the list of hardware somewhere on a screen. And cool, there's a list, unordered list items, and so on. But then someone from product or designer says, well, actually, let's put, a nicer list item there. And this is where I want people to start thinking about this. Okay, what's your first reaction to this, right? What do you want to do? You want to do a hardware list item component, right? Because that's the way our engineering minds work. And this talk mainly is about challenging some of those reflexes that we have, right? What we see whenever we come across change requests or just evolutions of certain things we were building, our mindset immediately wants to start breaking down things into components, break down things into files, and so on and so forth. So we come across the next iteration is, okay, we took the list item, we created the hardware list item component, we put a fancy icon in front of there, and then there's a big string which represents like how we display the hardware entry. And at some point someone says, well, actually that big string here is like error prone because it's inside JSX, let's put it in a function. And now we have a format hardware display label function. Cool, that's good. I'm not against doing this, and it's a good breakdown of how the hardware list is being composed out of separate different units. And again, these are code units, right? That's why we're talking about units, not components, because the function is also a unit here. Now, what's the next reflex we have here? Let's put them in files. So we build a hardware folder, and then we put our, and sorry for using JavaScript here, I just thought it's for some reason easier, but you can think of it as TypeScript. It's format hardware display label, it's hardware list component and hardware list item component. Yes, Eddie, thank you. And then, okay, what happens next? Not what happens next is rather what's an alternative to this. In some teams you might have something like this, where you have a components folder and you have a utils folder. This is so common that VS Code has icons for those folders, so it's clearly that people are using the folders in this way. So you have the components there and the utils there. And this is where the problems start to appear, because this function here is tightly coupled to the component, right? Ideally, we want it to be as co-located to the components as we can. That's why the first option would have been a better choice to kind of keep things at least at folder level co-location. The more extreme example here is that you start having each component in its own folder, then you have tests for it, and then you have other things for it there. I'm not sure if you've done this. I've seen code bases that evolve like this, and it gets really painful to navigate through like hundreds of index JSX files. This is a very bad pattern, by the way. Anyway, going a bit too extreme here. But coming back to this example, why this is good folder collocation is that you have your domain at the top, right? It's hardware. You know that everything inside that folder relates to hardware, so it's that kind of encapsulated unit. And then you have your collocated units, right? Everything that belongs to hardware lives under the hardware folder. And I know it's not going to be perfect like this. It's not like you can scale an application and have 100 folders with 100 domains and it will just work out. But you can think of this as more like how do you think about code and where do you put code into the big picture of the code base. What I would do here, again, even if it's not that simple, even if you have more complex, even if this file would be like, let's say 200 lines of code, my change would be just exporting hardware list there at the top. And this is basically file collocation. All you need from the perspective of this unit is almost like the interface of this thing. Everything inside hardware list is implementation detail. The fact that you have a list item component, the fact that you have a utility that formats in a certain way, even the fact that you're querying the data in a certain way. These are all kind of implementation details of this kind of single unit. And now you're thinking, okay, what the hell is this guy talking about here? Like, you want us to put all the code in one file? And I'm not saying we have to go to extremes here. I'm just saying that we're challenging here the mental model. Our engineering mind wants to break things down. But remember our initial goal. We want to build resilient code bases, right? If you're writing that code that I was previously showing, you might be familiar with it, and you're splitting it in files, and you're familiar with the files. But let's say someone else comes in. It's a different story, right? Maybe having everything in one file makes it easier for someone else to understand the code, look at everything, understand all the implementation details, and make the informed changes when needed. We'll get to that particular point in a second. But I talked about the idea of you write the code, someone else reads the code, right? If you think about, again, code as, and sorry if I'm being very abstract when I say code, just think about the code base and everything you're working with on a daily basis. There's a life cycle to that code, right? It gets written once, and then it gets read and modified, or read, and modified, and read and modified by other people or by you 2 years from now. And you look at your code 2 years from now, you might say, who the hell wrote this thing? And it's you, but the context is different now, right? So code gets written once and then gets read. And there's a ton of research done on how much we write code versus read code. And yeah, of course, everything reading code takes a lot more time. I'm pretty sure you've come through this problem where you have to read I don't know, 10 minutes of code to make one line change somewhere, and that's your PR. And someone says what took you so long? Well, I had to read through all the code. There are different proportions here. We have 3 reads for every write. You can have 10 reads for every write. This is a common thrown number out there that code is written once and then is read 10 times. But of course, every code base, and not all pieces of code are equal. If you write something that's on a very fringe of your application, you could not have anyone read it ever because it's just written once and it works. But if it's something very core to the way the code base functions, then it's probably read 100 times before someone makes another write operation on it. Anyway, we're going to look a bit at read and write cycles here. And again, even if read is more important from the perspective of how much time it takes, it is actually write that we're interested in when we're talking about colocation and resilience, because if you don't write it in a certain way, then it's not going to help with the read phase either. So let's look at how we write certain things, how technology helps us write code. And I actually wanted to take an idea from Ben's presentation as well, where he said something like React won at some point. And it just occurred to me while he was telling that this is actually the good explanation for my slide as well, because in my slide, what I wanted to argue is that actually JSX won. This idea of, this was React, sorry. This is React, this is Solid, this is Astro, right? This idea that all of a sudden we don't have your presentation and your logic separated in blocks, not even in blocks, right? They're actually collocated in the same, not only in the same file, but also in the same lines of code, right? You're no longer thinking, am I writing JavaScript? Am I writing HTML? No, you're actually doing JSX, which is basically, it's almost like an abstraction in terms of how you're thinking about the type of code you're writing. You're just expressing what you want to see there, whether it's dynamic code, conditional code, loops, or just static HTML in the end. So this is my argument for why JSX actually won, because the developer experience was superior because it allowed you to write in a collocated way without having to write your template here and then jump to another file to write the logic and write the data bindings, or jump to another file to do something else. Another good example is 10-stack query, React query, or similar libraries. But basically, I think React query is what really won here in terms of how we do data fetching. And why is that? Because it collocated the simple operation of just getting me a freaking list of data from somewhere and then rendering it in the same context, right? Collocating the data fetching with the way in which it is presented. And I know, again, that you're going to have more complex components and so on, but just this replacing something like Redux, which you had to write like 4 different files just to get a simple data fetching operation in the loop. This turned out to be a superior developer experience. So it kind of won as the de facto way of fetching data. One more controversial thing is CSS in JS, right? People are like, oh my God, this is CSS in JS. It's like, let's not talk about that. Well, style components is great because, again, it allows you to collocate styles in the React components. And what took it even one step further is the CSS prop that was introduced by Emotion, which allows you now to have styles at the same level with your JSX. So now I have the triad of HTML and JS and CSS, and you're writing it as you're thinking about the thing. It's the most extreme level of collocation, but when you're writing that, it really helps you. It creates this kind of, again, what I would consider to be a superior developer experience for all that. And last but not least, our favorite topic of debate today is Tailwind. And why do you think Tailwind actually won in terms of developer experience? Why do you think a lot of people are super passionate about building with Tailwind and hate it when they have to work on a project that no longer has Tailwind? Because they're taught now, their reflexes are rethought into not thinking actually about style anymore. When you're working with this combination of JSX plus, and this is not JSX, it's just HTML, but if you think about when you're combining all of them, and actually I have a video on this, right? This is me writing, I don't know, some component, right? And I'm not, in my mind, it's not like let's write the HTML, now I have to write the style, now I have to write the logic. No, your mindset is kind of rewired to think about just, I want to output this thing, and I know that I can style it this way, I can, semantically represent the tags this way, and I can conditionally render certain things, or I can loop over things, and so on and so forth. So this is very important because it allows you to not jump contexts, right? If you have to stop at any point, you have to define a class and then go to a style component, or go to a CSS file to define that class. You might just lose enough focus that your whole feature goes off the rails. And disclaimer, this is where AI kicks in. What is AI really good at, right? It's predicting the next token, right? The LLMs are great at exactly this model where, and actually I recorded this just this morning, where it looks like vibe coding, but trust me, I know exactly what the model is doing here because I understand as I'm typing things, the model is just a bit faster than me at suggesting, oh, you're using this technology, so I can already suggest to you, oh, these are the components, these are their props, oh, you're mapping over this is the callback, and so on and so forth. Styles as well, anything that makes sense. So your productivity really increases with a collocated mindset in terms of writing, and also with using things like AI. The fact that you give an LLM your entire context, it just loads everything, because of course they are also good at outputting code in 10 different files, but ultimately the LLM is at its best when they just have to iterate over a very short context, and they generate the better answer every time. And a lot of people are on the fence with AI, but honestly, if this is your entire use case of AI, it's great. It's absolutely, it's transformative in terms of how fast you write your code, and you don't have to worry, almost don't have to worry about all the downsides of generating code, because you are, again, in the context. You're not just telling AI to, go generate some components there for me, and whatever, YOLO. Anyway, sorry for the rant over. Okay, now we come to the read phase. That's it. Basically what I try to prove here is that technologies and frameworks and even methods of writing code that push you to collocate code will actually end up winning because of their, again, superior developer experience. Now, what happens in the read phase, right? Do these things actually help you with the read phase? And of course, my argument is that yes, they help a lot. Read phase actually means, with an asterisk there, means read and maintain code, right? Because You read code with the purpose of either making a change or understanding maybe some bug, but mostly to try to make some changes to that code. So you come across the hardware problem. You read hardware list JSX. Someone says you have to change the way the hardware entry, let's say, is displayed again. If you have the breakdown into files, you will read the hardware list. That throws you to hardware list item, and that throws you to format hardware display label. And I'm pretty sure you've had this problem where you had to go deep, like 10 levels, to really know where the hell do I have to make that change, in which component, because I'm looking at it, it's here in the dev tools, and I have no idea where it lives in the code, right? I know there are like ways to find that out more easily, but let's say for the sake of it that you don't have source maps or anything like that. The problem here is that if the change is only required in format hardware displayable, that's fine. It's just a kind of like a search problem, right? But if the problem involves changing somehow slightly in all of these layers, you end up losing a lot of like focus because you have to jump from one thing to another. When you're on the way back, you might say like, oh wait, where was I in the list item? Where was that thing? Like, you can very easily lose focus and get lost in your own implementation just because you have to. It's almost like a stack thing, right? And you can go so many stacks deep that at some point you're overflowing, I guess. Anyway, what I want to say with this talk, people are, whenever I talk about colocation, people are like, okay, it sounds good, like but when do I know whether, I keep a file, I keep all my components in a single file, does it make sense? Now, do I always do that? When is it actually a good idea? And what I'm trying to raise here is we need to change some of our reflexes, right? Whenever we come across a new way of doing things, or just a new idea, or just it might not even be a new idea. This is not a new idea at all. Whenever you come across this, your immediate reaction is like, when do I do it? And I think the change in mindset here is that instead of asking when should I collocate, you should ask when should I extract, right? By default, I write my code in a collocated way because that's better for developer experience. And now the art is, do I know when I have to extract these units into some other parts of the code base? And I came roughly with 3 categories of scenarios in which you should extract the code. And again, by default, you can collocate everything. So you extract for reusability, obviously. You don't have to worry about duplication. There is an argument here that sometimes duplication makes sense, but I don't want to get into that because you're going to throw tomatoes at me or something. But basically, when you know that you're reusing something, you can immediately extract that into someplace else. Just be sure that you are reusing it. Using it once doesn't mean it's reusable, right? It's reusable only when it's used at least twice. Now, not in the future. Unit testing, but this is an interesting one because the question is, should you be writing a unit test for that thing? And my answer is that only if it has a certain level of complexity, right? If a unit test for that format function is irrelevant, right? You should better just test the whole component as it is. So think more about this. I don't want to get into that testing debate, but there's this whole thing whether you should do more unit testing or you should do more integration testing. And you can choose whatever school of thought you want for that, but ultimately, unit testing should not be like just an escape hatch, like, oh, I need to extract all my components because they need to be unit tested. Why? Like, why don't you just unit test like the component as a whole? And then you have different domains, and this is where you start thinking in terms of like domains and does this code make sense to be, together with that, right? If you're writing the hardware component and you come across the need to show the user avatar, let's say, right? User is a different domain than hardware, so maybe user should live somewhere else. If you're doing user, most likely you're showing the user avatar in other places in your app, so that's like a shared component, right? But so the domain will kind of infer to you that, hey, this shouldn't be actually here. Okay, sorry, that sounded very weird. we talked about again, this is not chaos. Like we're not just outputting code in a random way in files. It's just again a mental shift, a change in some of our reflexes, right? Instead of role-based folders like components, utils, models, controllers, view models, whatever you have in there, we do domain-based folders, right? We do hardware. If your app is about people and shopping carts, you will have a shopping cart and a list card, whatever. You have products and stocks and SKUs and so on. One component per file. This is a rule that a lot of people follow, which I hate. You can do one component export per file, right? Because everything else is just implementation details for that particular component. Unit test, as we talked, becomes kind of like an integration test. It depends. It's a fine line between where you draw the line between them, and so on and so forth. So again, it's not about breeding chaos into your code bases. It's more about thinking and keeping code as close together, coupled code, keeping it as close together as you can. And if there's one thing I want to let's not spoil it. If there's one thing I want to leave you with this, and then I'm done, and you can throw your tomatoes. Again, our engineering mindset always comes first when our reflexes, right? And again, this is a matter of maturity as well. After so many years of working in the field, right? We've seen frameworks are at the mature level at this point, right? We professionally can say we are at a more mature level probably than maybe we were 10 years ago. Our reflexes will just push us into this, what is called accidental over-engineering, right? Sometimes it's intentional, right? You're really passionate about your type of architecture and you want to build it good from the first line of code. But more often you will hear teams say that, oh, we over-engineered our API. We didn't need actually 10 million requests per second. It's just over-engineered. Or the state management is over-engineered because we didn't need Redux to fetch data from 10 endpoints. Instead of doing accidental over-engineering, we should do intentional under-engineering, right? Defer abstractions and over-engineering and just all these things to the latest possible point, because it might just help out with this overall code resilience that we are looking for on the long term. Thanks.